Well, I changed my mind. We're not going to look at the animation. I'm just going to talk to you about this. So our second special triangle starts off with an equilateral triangle. So we know with an equilateral triangle, all three angles are 60 degrees. But the equilateral triangle is not our special right triangle because it's not a right triangle. We're going to create a right triangle by drawing in the altitude from one of those 60-degree angles. So what we're focusing in on is this triangle right here. And so I'm going to label with numbers just so we can get our reference triangle here and understand what's going on here. This 45, 45, 90 triangle has a hypotenuse across from the right angle. It has two legs that are not the same length. It's not isosceles because these angles aren't congruent. Remember, if you draw the altitude from the 60-degree angle, you're splitting this angle into half. And so each one of those is 30 degrees. You know that also because 90 plus 60 is 150, which leaves you 30 degrees for that angle right there. And so this is what's called the 30, 60, 90 triangle. It's our second special right triangle. And so what I'm going to do is I'm going to label the distance from A to D as 1. We're going to get us a reference triangle here. So I want us to understand from the equilateral triangle that if A to D was 1, then D to B was also 1, which means this whole side from A to B is 1 plus 1, which is 2. Well, since the original triangle was equilateral, all of the sides would have a side length of 2. So if we're focusing in on this special right triangle, we now know two sides of it. We know the short leg, the one across from the smallest angle, the 30-degree angle, is 1, and the hypotenuse is 2. And so we see, oh, this hypotenuse is double whatever this is. If this were 2, we'd have 2 plus 2 is 4, which means that side would be 4. So you can see the hypotenuse is simply double whatever the short leg is. Now, if we want to find the long leg, the one across from the 60-degree angle, we're going to have to use Pythagorean Theorem. But remember, don't put these values in for A and B. The 2 is across from the right angle. It goes in for the C. And so I can put the 1 in for the A or the B. It doesn't matter. So if we simplify this, 1 squared is 1, 2 squared is 4. So I could isolate the b squared by, oops, not sure what that little segment was for, but subtracting 1 gives me b squared equals 3. And we know we undo the squaring with the square root, and so b is the square root of 3. That is this long leg. And so that gives me my reference triangle. When the hypotenuse is 2, the short leg, the one across from the 30-degree angle, is half of that. It's 1. And the long leg is just the square root of 3, or in other words, 1 square root of 3. This is what we're going to use as our reference when we are solving a 30, 60, 90 triangle. We only have to know one side, and we'll know all three of them. So for instance, if I double this, if this one is 2, then I'd have to double it to get the hypotenuse. It's 4. And this side, instead of being 1 square root of 3, would be 2 square roots of 3. So as long as I know 1, I know all 3 of the sides. So that's question 8, your reference triangle. So let's look at Carlos stabilizing another tree, but he doesn't have room to move out 5 feet this time. He decides to use 2 wires on each side of the tree, each at an angle of 60 degrees. He is 3 feet from the base where he is standing. And we want to know how high up the tree should he attach the wires to stabilize that. And so what we have is a 30, 60, 90 triangle. The tree's making the 90-degree angle with the ground. He's standing at a 60-degree angle when he is 3 feet away. And so we know this other angle would have to be 30 degrees. And so this is our question, how to find this. Now, we have to make sure that we understand this is not the hypotenuse. The hypotenuse is across from the right angle. And so when we look at that 2 to 1 relationship, a lot of times students want that to be between the long leg and the short leg, and it's not. The 2 to 1 relationship is between the hypotenuse and the short leg. So if my short leg is 3, the hypotenuse is double that, it's 6. But that's not the number we're wanting here. We're wanting the long leg, the one across from the 60-degree angle. So we see if this short leg is 1, then the long leg is 1 square root of 3. Well, if the short leg is 3, then the long leg is going to be 3 square roots of 3. Whatever the short leg is times the square root of 3. So that's how high he needs to attach the wire. 3 square roots of 3, and our units again are feet. So if it gave me a rounding rule, I could put that in my calculator and round it to whatever unit it wants me to. But this is the exact answer, 3 square roots of 3. So let's look at some examples of the 30, 60, 90 triangle. Now the 45, 45, 90 triangle only had 2 rules. You either were multiplying by the square root of 2 or you were dividing by the square root of 2. The 30, 60, 90 triangle actually has 4 rules. So on this one, you're given the side across from the 30-degree angle. That's my short leg. Across from the 60s, my long leg, and across from the 90s, my hypotenuse. Remember, the 2-to-1 relationship occurs between the short leg and the hypotenuse. So if you're given the short leg, all you have to do is multiply by 2 to get the hypotenuse. So 2 times 10 is 20. If you're given the hypotenuse, all you have to do is divide by 2 to get the short leg. Okay, the opposite of multiplication is division. Now to go from the short leg to the long leg, anytime you're going to a bigger side, you're going to multiply. So I'm multiplying by something, but this time it's by the square root of 3. Using your reference triangle, you'll see that. So we're multiplying 10 by the square root of 3. So the long leg is 10 square roots of 3. If we were given the long leg and we want the short leg, we'd have to do the opposite. We'd have to divide by the square root of 3. So multiply by 2, divide by 2. Multiply by the square root of 3, divide by the square root of 3. There's 4 rules that could happen there. Anytime you go from something smaller to something bigger, you multiply. Anytime you go from something bigger to something smaller, you divide. So on this triangle, we've got to decide, what are we given here? I'm given the side across from the 60-degree angle. Remember, that's the long leg. Do not divide that by 2 to get the short leg. That's not where the 2-to-1 relationship exists. It's between the short leg and the hypotenuse. To go from the long leg to the short leg, you're going to have to do the opposite of multiplying by the square root of 3. You're going to have to divide by the square root of 3. So I'm going to take the 10 and divide by the square root of 3. Remember, you cannot leave a radical in the denominator, so you're going to need to rationalize by multiplying the numerator and the denominator by the square root of 3. So you're just multiplying by 1. So in the numerator, I have 10 square roots of 3. In the denominator, the square root of 3 times the square root of 3 is simply 3. Nothing will simplify that, since 3 and 10 will not simplify. So my short leg is 10 square roots of 3 over 3. Now I can go to my hypotenuse. You'll never go from the long leg to the hypotenuse. You'll always go through the way of the short leg. So remember, to go from the short leg to the hypotenuse, all I have to do is double it, multiply by 2. When you take 10 square roots of 3 over 3 and multiply by 2, the 2's in the numerator. 2's the same thing as 2 over 1. So you don't double everything. The only thing that gets doubled is this number outside in the numerator. The 2 times the 10 makes that 20. Remember, you won't double what's inside the radical, because the only numbers that are both under the radical multiply together. So you still have a square root of 3. And you won't double the denominator, because the denominator is being multiplied by an understood 1. So it's still a 3. So the only thing that doubled was this 10. And so we have 20 square roots of 3 over 3. So question 11 kind of brings it all together. I'm going to do that on a separate video.